Hello and welcome to an Autodesk Inventor tutorial. My name is Mr. Glindo, thank you for joining me. Today we're going to be creating our first programs within our first CAM setup. To reiterate, so far we had created an assembly, we then opened up the CAM environment, creating a CAM environment to our assembly, and we then created a setup which specified the stock material we're using to machine our car out of, the fixtures that we hold the stock with, and the actual model that we are going to be creating, as well as the orientation of the axes and their origin point or program origin. The next thing we're going to do is actually apply some programs to this setup. The programs are along the top here. They basically specify a kind of algorithm to calculate a toolpath for us. So, for example, the drill program will calculate a toolpath to then drill out some holes through your stock. The adaptive on the 3D milling option is going to be creating a toolpath to remove a large amount of material quite roughly, and that's quite specific. Now we're going to just look at one program at the moment, the drilling program, which I just selected, and to start with, because it's the first program we're selecting, we need to specify a tool, because our machine uses a particular cutter in this situation, and you can create programs with multiple cutters. Now I already have one here called the 6mm ball F1 cutter. You should already understand what a ball mill is because we've talked about it multiple times. If you don't know, you should probably go and have a look of it online. We now basically are selecting a tool by going to Tools, plus on my type, and then going to ball mill. You should be doing this even if the computer has already got the F1 cutter up, just to make sure that you're getting the right one. Once you get to the 6mm ball mills, there may be one that's called the F1 cutter, or F1. You're welcome to use it, but you need to make sure you go Edit and check that it has got the following attributes registered to it. So another student may have set this up on this computer that you're using. You may not know, and it's a wise decision to check that it's set up correctly, because otherwise it won't work when we put it into the machine. So, to start with, under General, the coolant should be disabled, number should be 0, all the rest of these numbers should match. If I don't speak about it, make sure it matches. High-speed steel is the material. The cutter, this is the actual technical bit that may be incorrect. Make sure it's a ball mill. Then, looking at the diameter here, it needs to be 6mm long. The shaft is 6mm at the other end. The shoulder length is 50, so this is the distance from the cutting tip all the way back down to where the shaft may change. We don't have a change, so it's the whole length. This is why it's the same as body, because the body length, which is the distance it sits out of the chuck or the holder, is going to be the same. The flute length though is 48mm. That's the length of the tool bit which actually can cut if it's moving through a material. That's 48mm. Overall length is 75, make sure units is millimeters. Okay, going to the holder tab, you need to make sure it's the BT30 blank one. If it's not, go select the holder option, and it should be just there at the top of the list, BT30 blank one, diameter of 1.81102 inches. I already have that, so I'm going to go cancel. Now we want to go to the feed and speeds options, and make sure that our spindle speed is 23,000 revolutions per minute. This is the speed at which the router, which is a motor, will spin this cutter. That's very, very quick. The feed rate then also needs to be specified at 3,500 millimeters a minute, and the cutter needs to also be a number of flutes too. Having done that, and if you would like to check any of the others, just make sure they are the same. You can click OK, and then you can select that tool. Once you have changed it, it can't be undone. Click OK. Now that you've got that, you can see here how our vehicle has got the tool bit hanging over it. Now I've oriented this pretty much identical to what it would be like if it was actually sitting in our machine, our CNC, and so this is what it would look like the first time. We're going to select drill cycle as we did, and we're now going to select the two axle holes that we want to drill out, the rear one and then the front one. Having done that, we're going to need to select the heights that we're drilling from and to. If we go back to looking at the side, you'll notice that there's an orange line, a grey line, there's a top height that's blue, which is kind of hidden, and a bottom height which is dark blue. You can see that there. The clearance height needs to be lower than it is because it's too high for our machine. If our machine tried to move up that high to do the clearance movement it does, what would happen is it would go, nope, can't do it, and it would throw an error screen at us, and that will crash the machine. So we'll make sure it's 2.5. Then for the bottom height, we need to make sure that this isn't too far down, and so we tend to select the origin, and then we go -4, because if we go, sorry, not 0.4, -4, if we go any further, the holder would actually hit the top of our vehicle. So we can only go down to -4. Clicking OK, and we now have a drilling program. We can watch this and simulate this by pressing the Simulate button, and you can see a representation of exactly what will occur if you place this code and press play within the CNC mill. And that is a program that you've applied to your setup. Well done. Thank you for watching, and we'll be making a few new programs in the next tutorial.